Hello everybody, welcome back to the channel. I'm doing a appendix to cover the complex numbers because I felt in the class some of you are not really comfortable with dealing with complex numbers, although some of you may learn in high school, right? So no matter where you learn, let's pretend we are back to the high school, maybe senior year, probably taking AP courses, okay? Because now we have this sort of the concept of the phasors, but right now let's see, we just deal with the complex numbers. I would like to give you a little bit of introduction of the number family, and so that we feel comfortable where these complex numbers are really residing in this family, okay? So if we roll the time back to, let's see, elementary schools, we started counting numbers, right? At the very beginning, we count 1, 2, 3. So those are only positive 1, 2, 3, and we learned how to count those ones. And those are only positive integers, and we call these natural numbers, right? So, and we also would like to associate these numbers with some sort of drawing or graph or figure, and we use what we call the number axis, right? So let's see if we label 1, 2, 3, 4, so on and so forth on this number axis. And each point on this number axis will correspond to the number we have. But we have a lot of gaps here, right? So we will talk about that in a moment. And later, then we just add a 0 to this. Also, we count -1, -2, and we have negative numbers, right? So in that case, we have 0, -1, -2, -3, -4. So these are all, so together, this become the integers. And the integers are the numbers that sometimes we call the whole numbers, right? So this could be positive or negative or 0. And then later, we added these decimals. The decimal numbers, and these are the numbers sitting in between these integers, right? So it could be anywhere on the axis. This has a sort of two different flavors. One flavor is we call the rational numbers, because some of the numbers can be the rational numbers. Those are the ones can be expressed as ratio, of integers, right? These are decimal, one type of, a lot of those decimal numbers are this type. And also there are sort of weird ones. The weird ones we call the irrational numbers, because they cannot be expressed in terms the ratios of integers. These are those ones that cannot be expressed as ratio of integers. So those are like a square root 2, pi, or the Euler number e, things like that. But in any case, now you occupied all this, so they're in between. Those are the decimals. So you have a decimals. Now the whole axis of the number axis, have been occupied, right? No room anymore. Completely full from negative infinity to positive infinity. So, and then the family wanted to grow, right? So what do? Well, what you do is add another axis, right? So all this this is the axis, this is the what we call this real axis, and we added another one we call the imaginary axis. And this family of numbers used to live on this real axis only, right? That's all the integers. Actually, we call it the real numbers, right? So that's the integers, the decimals, the all together and 0. They all together form the family of real numbers, and they live happily. They lived happily on this real axis, although very crowded, right? No any room. Each point has been occupied by a number, right? So now you add this second axis. Suddenly, your living space from that's a one line, one-dimensional, to two-dimensional. Now, what do we call this? A complex plane. Well, now how you represent these numbers? Well, we'll talk in the second part of this video. Okay.